Welcome back. In our last episode, we covered the basics of how a heat pump works and its main components. But in that video, we barely scratched the surface. There are even more critical parts inside your heat pump that keep it running. And when they fail, you'll definitely notice. So today's video is about listing all those components. In today's video, we'll be diving deeper into the hidden heroes of your heat pump, the components that most people don't even think about until something goes wrong. From sensors to capacitors to backup heat sources, this is your complete guide to heat pump internals, so stay tuned. Have you ever wondered why your heat pump sometimes turns into an ice block? Well, the defroster board and the sensors prevent that by detecting ice buildup and triggering a defrost cycle. But if the defrost board or the temp sensor fails, your heat pump might freeze up completely, leading to poor efficiency, a constant running, or even complete failure. Think of these as the starter and relay switch for your heat pump. The capacitor stores and releases electrical energy to start the compressor and fan motors, while the contactor works to provide power flow. If your heat pump makes a clicking sound but will not turn on, or if the fan struggles to start, then these little components could be the culprit. Refrigerant is the lifeblood of your heat pump, transferring heat between the indoor and outdoor coils. If your system's low in refrigerant, it won't heat or cool properly, and running it that way can damage your compressor. Refrigerant leaks or incorrect charge levels lead to weak performance, icing on the coils, and skyrocketing energy bills. A heat pump moves air using two key motors: the blower inside your air handler and the condenser fan motor in the outdoor unit. If either fails, your system won't be able to circulate air properly. A failing blower motor means weak or no airflow indoors, while a bad condenser fan motor causes the outdoor unit to overheat and shut down. This small but crucial component removes moisture and debris from the refrigerant, preventing contamination that could clog your system or damage internal components. In colder climates, compressors need a crankcase heater to keep refrigerant oil from thickening and damaging internal components upon startup. If this little heater fails, your compressor could struggle to start, or worse, seize up completely. If you live in a colder climate, your heat pump likely has electric heat strips as a backup. These kick in when the heat pump alone can't keep up. While they are very useful in extreme cold, heat strips consume way more electricity, so if yours runs constantly, something is wrong. Your indoor blower motor has its own breaker inside the air handler, separate from your main electrical panel. This breaker protects the motor from power surges and overloads. If your indoor blower motor suddenly stops working, check this breaker first. If it's tripping repeatedly, you could have a bigger problem, like a failing motor, a bad capacitor, or even an electrical short. The transformer inside your air handler converts high voltage, usually 120 volts or 240 volts, to low voltage, 24 volts, which powers your thermostat and control board. Without it, your heat pump won't even turn on. A bad transformer means no power to the thermostat, no signals to the heat pump, and no heating or cooling at all. The low pressure switch, or the LPS, is a safety device that shuts off the compressor if refrigerant pressure gets too low. It's usually due to a leak or restriction in the system. Running a compressor with low refrigerant can cause severe damage. The high pressure switch does the opposite. It shuts down the system if refrigerant pressure gets too high. This usually happens if the coils are dirty, airflow is blocked, or there's an overcharge of refrigerant. I posted a previous video where I went into detail about changing a high pressure switch. Watch that video if you need further assistance on that high pressure switch. The low pressure switch changes exactly the same. That is every hidden part of your heat pump fully explained. Don't let this full list overwhelm you. We will be doing subsequent videos for this series on each part, how they function, what to look for to fix them, and what some of the signs of them going bad are. Got a weird issue with your heat pump? Drop a comment below and we'll try to figure it out together. In episode 2 of this series, we'll go into troubleshooting 101, starting with the thermostat. So if you haven't subscribed, you may want to do that now so you don't miss a single episode.